So these are on page 307. A little different than what we did before. So we're not using, we're using part 2 of the fundamental theorem of calculus. So we're going to find the antiderivative and then evaluate it at the upper limit, lower limit, and subtract. So we have to do the antiderivative. So think about the reverse of the derivative. So remember when we took the derivative, we did the power rule and decreased the power. Now we're going to be increasing the power. So we're going to take x, we're going to add 1 to the exponent, so we'll get 5/2. But then we have to multiply, or we have to divide by the new power. So instead I'm going to multiply by 2/5. Now double check. Take the derivative of this and you should get x to the 3/2. So notice that if I did the power rule, I would have 5/2, that's going to cancel the 2/5, x to the, and then I would subtract 1 whole, so that gives me x to the 3/2. So then I'm going from 0 to 5. So I'm going to pull the 2/5 out, and we have 5 to the 5/2 minus 0 to the 5/2. Well, this is just 0. So I need to think about this, what this value is. So we know that, I'll just kind of do this off to the side, that the bottom number is the root, so it's the square root of 5 to the 5th power. Well, think of this as the square root as 5 squared times 5 squared times 5. So I'm taking the square root of 5 squared, so I can pull a 5 out. I can do it again. So I get 25 root 5. So that's what this simplifies to. So I have 2/5 times 25 root 5, and we get 10 root 5. Now, you can check these on your calculators using finite. So if you go alpha and hit the window key, and we want number 4. So we're going from 0 to 5 of x to the 3/2 power dx. And you're going to get a decimal answer, but if you check that against 10 times the square root of 5, whoops, that wouldn't work though. Let's try that again. 10 times the square root of 5. And then you see you get the same thing. Now notice it's a little different, and that's because finite uses an algorithm that's going to be an approximation. 10 root 5 is better, but you just need to be correct to 3 decimal places, and we would be, even using finite. Okay, so next problem. I'm going to first think of this as the integral from -2 to -1, 2 times x to the minus 2. So then we want to increase our power by 1, so that's going to mean that's going to be x to the minus 1. And then we're going to divide by the new power, which dividing by a -1, so we want this to be a -2. Notice what happens if I do the power rule. I would multiply and I get a positive 2, x to the minus 2. So then you can just always double check and then you'll know you're right. Okay, so then we're going to be plugging in values. So if I take, now if you want, you could switch this to -2 over x. So we're going to get, if you plug in a 1, so you're going to have -2 over -1 minus -2 over -2. So we get 2 minus 1, which is 1. Okay, so for the next one, we're taking the integral of a sum, which you can split it into the 2 parts. So you could do the integral from 0 to pi of 1 dx plus the integral of 0 to pi of cosine x dx. Okay, so then we're going to take the antiderivative of this is just going to be an x. The antiderivative of cosine is sine. And then we're going to plug in, so we'll plug in a pi minus 0, which is just pi, plus, and then we're going to have sine pi minus sine 0. Well, sine of pi, think of the unit circle. Sine of pi is 0. Sine of 0 is 0. So we just get pi for our answer. And if you finent this, you could do that. I'll leave that for you. But you could finent this and you'll get pi, but it won't be the symbol pi. It will be the approximation. Okay, so on the next one, you can actually pull the 4 out in front of the integral. And then you have to remember, we're going to have some other techniques and strategies later for some more complicated functions, finding that to evaluate the integrals. But on this one, you kind of need to go with recall. So think about what function, what trig function, if I take the derivative of it, do I get secant x tangent x? And that actually is secant x. So again, that would just be one you would remember, hopefully. So the 4 is going to be out front, and then we're going to take secant x and evaluate it at both of the limits. So we're going to have secant of pi over 3 minus secant of 0. Since it's a pi over 3 angle, and if you forget, if you don't have, if you need to think about it a little bit, this would be pi over 6. That's the 30 degree. Pi over 3 is 60 degrees. So we have 1, 2, square root of 3. And secant is the reciprocal of cosine. So if cosine of pi over 3 is 1/2, then secant is 2 over 1. So secant of pi over 3 is 2. And secant of 0, you would have to remember what cosine of 0 is. Not from a triangle, but from the unit circle. Cosine of 0 is 1. Remember, think of the unit circle. And the value at 0, the ordered pair would be 1, 0. And remember, the cosine values are the x coordinates. So we get 4 times, we had a 2 minus 1. So 4 times 1 is just 4. And you could finent this, and you will get 4. So this one, when you first look at it, seems really complicated, and you might wonder, how in the world am I supposed to know what the antiderivative of this is? What you want to do first is do a little algebra and simplify it, and think of this as 1 over the square root of u minus the square root of u over the square root of u. So then we can think of this as the integral from 0 to 4. Remember, this is u to the 1/2, but since it's in the denominator, it's the negative 1/2. And this is just 1. So then we get so here we'll have, remember, you increase the power by 1, so we have u to the 1/2. Divide by the new power, which means I multiply by 2, so you can double check it and see that you get that. We'll plug in those values. And then here, the antiderivative of 1 with respect to u is just going to be u. So now if we plug in a 4, we're going to take the square root of 4, because that's what the 1/2 power means. So the square root of 4 is 2. Then we have times 2 is 4. Plugging in a 0 just gives us 0. And here we plug in a 4 and plug in a 0, which of course gives us 0. And 4 minus 4 is 0. So all of that for 0. And you can finent that and verify your answer. Okay, one really common thing we do with integrals is find the area under the curve. So here we're going to find the area between the curve and the x-axis. We are given a function which hopefully you recognize as a quadratic function, and only between the values of -2 and 2 for our domain. So I started by, I scaled my horizontal axes just by 1s and my vertical axes by 2s. I knew the vertex was 0, -3. It's stretched by 3, so over 1, up 3, paying attention to the scale. And then over 2, up, it would have been up 4, but multiply by 3, so it's up 12. Again, paying attention to the scale. So to find the area we're looking for, it's between the curve and the x-axis. So it's going to be this part here, and this part here. Okay, and we want to find the total area. So if we were just evaluating the integral, we could do that. We could just go, if we were just doing the integral, we would just do from -2 to 2, 3x squared minus 3 dx. But that's not going to tell us the area, because part of this is above the x-axis and part of this is below. This is considered positive, and this is going to show up as a negative when you just integrate it. So we need to flip this up to the top. So one way to do this, so this won't give us our answer. So one way to do this is we want to integrate from, notice this passes the x-axis at -1. So if we integrate from -2 to -1 of my function, and then instead of going from -1 to 1, I want to change the sign. So I'm going to subtract, I'm going to change it to the opposite and go from 1 to -1. I forgot my dx. And then I'm going to add to that my integral from 1 to 2 of 3x squared minus 3 dx. Okay, actually in thinking about it, I changed this twice because I changed this to the opposite, and then by switching these, that changed this to the opposite. So I'm going to leave this a plus since I already have those that way. But I do need to change because I need this to be considered the opposite sign. So going on from there, the antiderivative of this function is just going to be x cubed minus 3x, and that's going to be true for each piece. So we're going to have x cubed minus 3x evaluated here. When we do that portion, we'll have a -1, plugging in here, plus 3, minus a -8 plus 6. So that gives me a 2 minus -2, which is 4. Then for this next piece, we're going to have from 1 to -1, so we're going to end up with, it's still going to be a 2 on this one, because I'm plugging in the same values I just did. And here I'm plugging in a 1, so I get 1 minus 3. So we have 2 minus -2, also 4. And then we have the last one, x cubed minus 3x. Oh, actually, in this, notice that this is going to, it's symmetric. So this piece is going to be the same as this. So we'll get that same answer, but I'll just show you this way. So we're going to have 2 cubed is 8 minus 6 minus, plug in a 1, we get 1 minus 3. So 2 minus -2, also 4. So then we are adding those together. So we get 4 plus 4 plus 4. So we get 12 square units for our area. Okay, so for this last one, number 46, we're finding the area of the shaded region. So notice that this portion of the curve is y equals the square root of x. So I'm just going to draw a dashed line there. And then this portion is y equals x squared. So we're going to integrate from 0 to 1 of the x squared, or the square root of x portion of this. And then we're going to add to that the integral from 1 to 2. We don't have to worry, there's nothing below the x-axis like on that last problem, so we don't have to worry about that. X squared dx. So again, I can think of this as x to the 1/2. So when we do the antiderivative, we're going to get, don't know where the u came from. We're going to get x to the 3/2 multiplied by the, divide by the new power, which means I multiply by the reciprocal, and you can verify you would get that from 0 to 1. And here we're going to have x cubed over 3 from 1 to 2. So then when we plug in a 1 here, we're going to get 1 to the 3/2, which is 1 times 2/3 is 2/3. Plug in a 0, you get 0. Plus, we plug in a 2 here, and we're going to get 8/3. Plug in a 1 here, and we get 1/3. So we have 2/3 plus 7/3, which is 9/3, which is 3. So 3 square units would be our area under the curve. So that is it for the examples from this section of your assignment. So hopefully that gives you a little bit of help on doing those problems.